Hey guys, today I'll be taking up question 4 of the AP Physics 1 2024 exam. So here we have a simple pendulum consists of a small sphere that hangs from a string with negligible mass. The top end of the string is fixed. The sphere is pulled to point A so that the string makes a small angle theta with the vertical as shown. The sphere is then released from rest and swings through its lowest point at point B. The work done on the sphere by Earth between points A and B is WE. And then it is taken to planet X, where the mass is the same, but the radius is greater than that of Earth. The sphere is then brought to point A, displaced theta from vertical, and released from rest, and it swings through its lowest point at point B. The work done on the sphere by planet X is Wx, and we have to justify why Wx is less than We. Well, first of all, before anything, we would write the formula for work. Work equals force times distance. And the second step I would do is ask you to justify why the work on X is less than the work on E. So we would list all the differences we see between Earth, the system on Earth, and the system on the planet X. So it says that they both make a small angle theta from point A to point B. So this system stays the same. The length of the string and the mass of the sphere is also the same. So this complete system is the same. However, the only thing that it says it's different is that the radius of planet X is greater than that of Earth. How will we use that? Well, what will be our force in this formula? We know distance is the same. The pendulum goes the same distance, but what will be our force? Well, force is very dependent. The only driving force here is gravity. So force here would be proportional to gravity. So Fg equals, and it's given by G m1 m2 over r squared. M1 and M2 are the same. M1 is the mass of the planet, M2 is the mass of the sphere. But the R of planet X is greater. So if the R of planet X, if the radius of planet X is bigger and everything else stays the same, then what does that do to our force? It ultimately decreases our force, and that in turn decreases our work. So we would just write down everything I've said. Uh, the force of gravity on planet X, first we can see that it's inversely proportional to the square of the radius. Is inversely proportional to the square of the radius. And I will leave it here. However, furthermore, the mass of the planet X and Earth are the same, and the mass of the ball is the same, and G is a constant. It's the universal gravitational constant. So since R increases for planet X, the force of gravity on planet X is less, because if R increases, then F of G decreases. This, in turn, ultimately results in a uh, lower work and less work on planet X, because work is proportional to the force done. And it would be nice to mention that the distance the distance stays the same, because we have to mention all the things in the formula. The distance of the ball, distance that the ball travels, stays the same as well. And yeah. A new pendulum is made by hanging the same sphere from a different string with negligible mass. The new string is slightly elastic, and the length of the string may increase or decrease depending on the tension applied to the string. On Earth, when the string is again displaced theta from the vertical and released from rest, the new pendulum oscillates with period Te. The new pendulum is then taken to a different planet, planet Y. The radius is the same, but the mass of planet Y is larger. On planet Y, when the sphere is again displaced from vertical and released from rest, the new pendulum oscillates with period Ty. And now we need to explain how Ty could be larger than Te, but also could be smaller than Te. Before anything, let's take what we know from this. We know that this incorporates pendulum oscillation. So what is the period of a pendulum oscillating? This is given on your formula sheet. The period would be equal to 2 pi root length over g, where L is the length of the string and g is the force of the acceleration of gravity. So what factors do we have here that are different? Well, the length and gravity are both different. So this is because the length could stretch, which increases on planet Y, and g also increases on planet Y, because f of g is given by g m1 m2 over r squared, and if m1, the mass of the planet, increases on planet Y, the force of gravity increases, and when force of gravity increases, the acceleration due to gravity also increases, because it's just force over mass. So looking aside from the length, we could directly just write the period of the Ty could be greater than, could be less than Te, because we know that the force of gravity on planet Y is greater. And as we can see from our equation, the period is inversely proportional to the square root of gravity. So if g increases, then the period ultimately decreases, because the force of gravity on planet Y is greater than that on planet T. On Earth. And we would say the formula g m1 m2 over r squared, and m1 increases, which in turn increases the acceleration due to gravity on planet Y. And, or other words, that would be symbolized as g. When this increases, then the period of the pendulum decreases, as it is inversely proportional to g. Inversely proportional to the square root of g. Next, we have how can Ty be more than Te? Well, the only other factor is the length. We know that g, no matter what, g would always be greater for planet Y, because the mass of planet Y is always greater than the mass of Earth. Well, how can the length be greater? Well, the question states that the new string is slightly elastic, and the length of the string may increase or decrease depending on the tension applied to the string. So we need to find how tension is affected. If you already know why, you don't have to say this, but I will just draw a free body diagram of all the forces on the block. So first of all, there's gravity, and the only other force would be the tension force. So as gravity increases, on planet Y, then the tension force must also increase on planet Y as well to keep the object in equilibrium. Sorry, in like that current position. So that means that the tension force on planet Y is greater. Ft on Y is greater than Ft on Earth. And why is this important? Well, when tension increases and the string is elastic, that means that the length of the string also increases. So if the length of the string also increases, that means that Tp would also increase if the increase in length outweighs the increase in G. However, a greater gravitational force on planet Y leads to a greater tension force on the string. And this greater tension force, this greater tension force leads to leads to the string being stretched more and increase in length. And when it increases in length, then L in this formula increases. When this happens, if the increase in length is greater than the increase in the acceleration of gravity, the period would ultimately increase on planet Y. And because L and G both increase, like G increases no matter what, and L increases because of our logic. But if the spring is very elastic, it's very stretchy, then L would increase a larger amount than G, which ultimately results in an increase in the tension. However, if the string is not that elastic and pretty hard to stretch, then L would increase a smaller amount than G, and that would result in the tension of the period of the pendulum being less on planet P. I hope that helps you guys, and yeah, thank you for watching.